video will cover section 10.1, part 2, and it's being recorded during third period. So if you are in my first period class, you know we got a little further than this, so you may fast forward if you want, but don't skip anything, because I'm recording for you. So let's go over what is the factorial notation. And so what this is what happened? Did I close it? The printer? So factorial is something that maybe you guys have not seen. However, it's a very useful operation. And what it implies is multiplication. And it's going to be and we use the exclamation sign. Okay, it doesn't mean you have an excited number. It's just the product of the integers from that number to 1, like that. So then if let's start from the top. So for 1 factorial, it's just 1. For 2 factorial, it will be 2 times 1, which is 2. For 3 factorial, will be 3 times 2 times 1, which will be 6. 4 factorial, 4 times 3 times 1. I'm sorry, I skipped 3. Yeah, so don't skip, and you only consider the integers, okay? 2 times 1, so that will be 24. 5 factorial, 5 times 4. Go ahead and keep working. 5 times 4 times 3 times 2 times 1, so that will be a 120. And then 6 factorial is 6 times 4 times 3 times 2 times 1. Why do I keep doing that? I skipped the 5, right? Okay. So 6, 5, 4, 3, 2, 1, and that is 720.
I don't think
We don't have that.
Yeah. I think you're doing the wrong one.
you skipped to like example 6 on this one.
On 10.1,
So again, the factorial means that you take all the numbers and then you multiply them, all the integers, not all the numbers, sorry, from the number until, so for example, this one here, if we have a 10 factorial, it will be something like the first number will be 10. The next number you guys see is n minus 1, so if I say n is 10, what is n minus 1? 9. And then if n is 10, what is 10 minus 2? 8.
And 7.
7. And you go all that way, and you guys see this like 3 dots? That implies that there are numbers in between. And the last 3 will be like 3 times 2 times 1. Okay? If we had something like 100 factorial, that would be a huge number. And it will be all like 100 times 99 times, and so on. All right? So I'm going to show you some tricks to cut a little bit of work, like some shortcuts. So for example, well, one thing that we must point out, if I was to ask you what is 0 factorial, what would you tell me? It makes sense, right, that it will be 0, but it's not. It's actually 1. And do not ask me why.
Why?
Because it is by definition. That's why.
Oh.
Okay? Just by definition, you take it, that's it. No questions asked.
And wait. So
Nope.
these factorials, what are they used for?
They're used in computer science a lot to calculate huge numbers.
Oh.
Yeah. Also to simplify. Or to write general terms like this one. For example, here, they're actually used in probability. I want you to look at something between the 6 factorial and the 5 factorial. So, isn't it true that the 6 factorial has 5 factorial included into it? Right? Okay, so that's going to come back to us like an example.
Oh, and doesn't it like cancel out if you?
Exactly. So that's one of the tricks that we're going to be using.
Yeah.
Wow.
I
So
that.
first of all, let's do this example 3, write the first 4 terms of that sequence. So a sub 1 is going to be 2 to the first power over 1 minus 1 factorial. So first we have to do what's in the parentheses. So what is 1 minus 1? 0. So we're going to have 0 factorial. And 2 on the top. So then don't think it's undefined, right? It's actually 1. By definition. So that is 2. Let's find the next term. So we have a sub 2 is 2 to the second power, and then here we have 2 minus 1 factorial equals 4 over 1 factorial. So that would be 4 over 1, which is 4. Okay, so try to do the next 2 by substituting. And then just occasionally glance to my board so that you're on the right track. So you're substituting the n with the subscript. That's what you're doing. The n here for the exponent and the n here inside the parentheses.
Can you put the exclamation point in the front of it?
Yes. And it's actually, that's a great question. The factorial, guys, there are 2 ways that you could enter it. One of those, if you go to your, okay, well, there's one for sure that I know. If you are in the calculator section, and then you go to menu, there are some, I'll show you now. There are some options. There are some options here. And so for example, let's say I want to put 4 factorial. So it's 4. Okay, 4. And then I can go to menu. And then in the probability menu, you could find it there. It's the very first one, factorial. And then it will tell you the number. The other way, where's like the library of symbols? Do you guys remember? I can't remember. It's not there. No. There's another one. I can't remember. Oh, it's right here by the comma. So it's right below pi. And if you press that, oh, never mind now. I was wrong. Oh, I found it. It's next to the letter G, on the right side of G. You see a question mark and the exclamation sign, or point, whatever. So if I can say 4, and then press that button, this one here, below enter, and then it will be the second one on the top row. Okay. So going back to the slides. Check your work, please. So here we got 4 minus 1 factorial, so it will be 16 over 3 factorial, so it will be 16 over 6. Yeah, is that?
I have a question. 2 factorial is 2?
Yes, because it's 2 times 1. 3 factorial is 3 times 2 times 1.
So you're going to write 2?
Yeah, you should.
Oh, we didn't finish it. So 2, so it will be 4. And then here, 3 factorial is 6, so we're going to have 16 over 6. We can simplify it, so it will be 8 over 3. Can we take factorials of decimals? No. I actually had a classmate in graduate class who presented about that. No.
Wait, can you go back?
No. So if you guys notice, the formula is defined as n being a positive integer. So can you get factorials of negative integers? No. All right, so next slide. We're going to simplify some by canceling out, like Andrew said earlier. So for example, 10 factorial will be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's it. And then on the bottom, I have 2 factorial. I'm going to leave it like that. And then I'm going to have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So then I can cancel the 1s, the 2s, the 3s, the 4s, the 5s, the 6s, the 7s, the 8s. And that's it.
So it'd be 90 over.
So what I did, let me explain it again. So we have 10 times 9, and then this whole thing actually represents 8 factorial. So then with the 8 factorial on the bottom, I just did this to demonstrate why. But with the 8 factorial on the bottom, automatically that will disappear. And what are we left with? 2 factorial, which is just 2 times 1. So this will be 90 over 2, which is 45. Okay, so let's try the one on the bottom. So you have 14. So you have to start with 14 times 13, and then instead of going all the way from 12 all the way to 1, we can shorten that by using 12 factorial. And then here we have a 2 factorial in the denominator, but we also have a 12 factorial, and that's why I decided to stop at 12, right? So 12 factorial cancels top and bottom because that's equal to 1. And then here we just need to multiply 14 times 13.
182.
Thank you. And 2 factorials are 2, so that will be 61. Okay, now let's
No,
look
it's
at...
91.
Oh, yes. Oops. Okay, now let's go back to the ones that have letters, all right? Now don't worry, it's not the end of the world. So if I had told you I want let n be 5, right? How would you write this expression here? It will be substitute. Well, the first 5 plus 1, and then over 5 factorial, right? Or 6 factorial over 5 factorial, okay. And then you already know that you can do this. 6 times 5, instead of going all the way 4, 3, 2, 1, we just use 5 factorial. We have 5 factorial on the bottom, that cancels out, and we just get 6. Yeah, do we all agree? Okay, now I'm going to do it with letters, okay? So n plus 1 factorial over n factorial. So what is my biggest term on the numerator? The biggest. The one I should start with. N or n plus 1? N plus 1. That's the biggest. So n plus 1 is the first term. Now, if I subtract 1 from 1, what is my next term? Just n. And if I want to say n factorial, that will be like all the way from n all the way to 1, right? However, I can just use n factorial to save me trouble. And then what do I have on the bottom? N factorial. Cancels, cancels, so the answer is n plus 1.
Or 6.
Well, n was 5. Okay, now let's look at this one here. So which one is the biggest term? N or n minus 1? N. So we start with n. And then what will be my next term, like one less? N minus 1. Very good. And factorial, right? Because I don't want to write all the times 5, times 4, 3, 2, 1. And then what do I have on the bottom? N minus 1 factorial. So cancels, cancels, you get it. Yes. Those little tricks are so useful if you ever take a statistics probability class. So the reason we're learning them now is because in this chapter we're still going to cover some of the, we call them combinations and permutations, and we have to have knowledge of the factorial. But don't worry, your calculator can also check your work for you. All right, so next slide.
Wait.
I'm writing too slow.
No, it's
Oh, it's because I don't have the notes. Do you guys have the next slide? by any chance? Are you serious? You got it?
Yes.
Anyone else still writing? Jamie? I know you. Okay. What's this? Okay, don't copy that, please. Don't.
Oh, dang it, I was like,
No. Okay, so let me explain to you quickly what it is. So, and this is like very old school, well, like 12 years ago, based on some research from the U.S. Department of Agriculture. It was established that a middle-income family raising a newborn, a child who was born in 2006, will spend approximately a total of $260,700 raising one child. So you know that misconception that like the more kids you have, the more you get back in taxes. Like people actually deserve it because it is very expensive to raise a child. So like, I don't know how you do it, Harrison. Well, your parents. So how many siblings you have? 4? 5. So you're number 6? You're what? Oh, whoa, I know. Okay. But like, you guys had a total of 6. Oh, whoa. Whoa. Okay, so let's look at the prices. So is it surprising that a newborn is less than a 17-year-old? Like, will cost less?
yes.
Some people think they cost more, yes, because like they need a lot of stuff, right? But their stuff is kind of cheap. Like compare like a little baby pair of jeans, you know, and then like an adult, a 17-year-old, like especially the one newborn and stuff, right? So we have here, and then plus you get all the stuff from the baby shower, you know. So yes, you might use like formula or you could save money if you breastfeed your kids, which I will suggest all of you ladies to do that because you will make your kids smarter and healthier. It's a fact. There's like tons of research on it.
Just the ladies?
I'm like, no, we'll discuss that in another lesson. But I actually want to become like a breastfeeding coach. They have those in El Paso.
What?
So when new moms are struggling, they can call you.
Miss, you want to be everything?
I know. I know. Huh? Labor coaches, yes. But yes, please consider that. I don't think they take men. Let's try. Okay. So anyways, as the years go by, right, you see the cost is increasing. And then here the child, maybe here they bought the child a car and, you know, college applications. So yeah, it makes sense. All right, so if we wanted to represent all of that, we will use this symbol right here. So do copy that one. And it will be, it's called Summation Notation. And yes, summation is a word.
Aren't those easy? Or is it kind of like
So
the exclamation points?
we could have it with exclamation points. In fact, how do you guys say add in Spanish? Sumar, right? Suma or addition is the suma. So summation, yes. And so that is the sigma letter, Greek letter, and that implies summation. What is it? So what? Yeah. So let me tell you guys what they're called. So the index of summation is this little letter down here, and it's also called the lower limit. So like your starting point. So in this case, you start with 1. So here we started at when the child was under 1. I guess this could have been like a 0. All right, so then the number on top is going to be the upper limit. The ending, yes, the ending point or the last term. And the bottom one will be the first. Now, do you have to use I? No, you could use other letters. The most commonly used are N, I, and K. And don't think about I as an imaginary number, okay? Don't. This has nothing to do with that. Oh, okay, what else? So let's do the examples. Do you guys have that, sir?
No.
Is the one that I just passed to you? Okay.
Yeah.
We'll copy those, please. Let me make them bigger.
6.
I know. Peter, copy those. You did, Irene? Come on, because you're about to leave. You guys, I really don't want you procrastinating on your review, okay? At this point, I want you to think of my class as the most important class that you have. Yes, I did say that, Mr. O'Kee. Who else you guys have? Martinez, Alonso. Yeah, guys. Garcia. Because my class is a 4-credit class, you know. Plus math is like more important. Huh? Yes. It's your shape. And you have an exam coming up, and you really need to get a good grade. Very good grade. You could still pull yourself out of that hole. Maybe you could still get that 3.0 that you need. Hey, if you guys get an A in this class, your GPA will jump like 0.5.
What if we got an A in the last semester?
I calculated on us, just in case you want me to help you with it.
Wait, what if we got an A on last class?
Huh?
If we got an A on the last class? Or
You got an A on the last
semester?
one? That one is a 3 credit. This semester is 4 credit. Okay, do you guys copy it? Yes? Yes? Did we all copy it? Okay. So, we need to evaluate the sum. So, we're not only going to find the terms, but we're also going to add them. Okay? Because we're using the sigma, which implies position. So, for part A, the first term, we start with I equals 1. So, we're just going to substitute like if it was a function. So, 1 squared plus 1. The second term is going to be, we move 1 on the integers. So what's after 1?
2.
2.
And then we reach up to 6. Right?
So 2 squared plus 1, and then we go all the way to 6. So let's write it down. So first you do the substitution, and then you have 1. Well, I'm just going to try to do it faster. So we will have 1 plus 1, that's 2. No, I'll just write it. Okay, so 1 plus 1, and then 4 plus 1, and
9
then
plus 1,
9 plus
16 plus 1, 25 plus 1, 36 plus 1.
Okay, so then what can we do? Well, we do what's in parentheses first, so it will be 2 plus 5 plus, and then here 9 plus 1 is 10, 17 plus 26
Plus
plus
7.
30,
7.
and there we have it. Now, is there a way to do it on the calculator? Of course, you can add them all, but you could do something else. Go to menu. Let me see. And then select the calculus. Oh, I shouldn't be teaching you this, but okay. Select the calculus menu, and then you go. Oh yeah. Remember how to find factorial? I told you go to menu and then probability. Correct? So now to do that type, you could use menu, calculus. From here, instead of probability, you click calculus. And then you go where it says sum. And look how beautiful it looks.
What? You just did the whole thing for us?
Wow.
Oh, technology.
Wait, where do we go? Oh, sum.
But what if I ask you to expand it on the test?
No.
You still need to substitute, right? And then you can check your answer with the calculator, of course.
Unless your phone's ringing.
Okay, so part B, we do that, we write them down. And then Jaleet's asked a great question, are we always going to be adding? Well, if you get a negative sign, then you will subtract. But you know, subtraction is the same as addition, it's just with negative numbers.
You're just combining it.
Yep. So then -2, if it's an even power, what are we going to get?
You're gonna get a positive.
Positive. If it's an odd power of a negative number, we get negative. So the powers here, power of 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, and then 2 to the 7 is 128.
Yes.
So those are the numbers I'm going to use. However, I'm going to have alternating signs. So 16 minus 5, 16, I'm sorry, -32 minus 5, and then we will have positive 64 minus 5, and then we're going to have negative 128 minus 5. And then go ahead and do what's inside the parentheses, please. Okay, guys, so then we add, or we do what's inside the brackets first, and we're going to get 11,
-37.
then -37,
59. I mean, 59.
and then positive 59,
What's negative?
not going to answer. That's it, I'm done, I'm done. 133. Who's that? Oh, who's Harrison, right? Okay, bye. So we get -100. Great job, guys. Now, the one here, do you guys see this one here? I'm going to make him small again, okay? I need that space. So you guys see, here we only have a number 3. We don't have any variable to substitute. So what are we going to do?
You just multiply it by 5.
No. So what will be the first term? The easiest you can think. No.
4.
What would you say another? 3. What's the second term? 3. What's the third term? 3. And 3.
Oh,
And
so
3.
it's
So
like
it doesn't matter because you don't have an I to substitute. So every single term will be the same.
So you basically multiply it by 5.
Yeah.
Correct.
Oh.
So then this will be 15. And we do it 5 times because our upper limit is 5. All right. Now, well, let me give you some time. You do have the last slide, right? Okay. Okay, so we're obviously not going to get to 10.2. So what do I want you to do with 10.2? If you're going to go to YouTube, yeah, I'm sorry, but yes. Because I need you guys to, on Monday, be done with all your homework. Because your test will be on Wednesday. So please, please, please. It's for your own good. I will make it short, I promise. What if I make it very short? Like a 30-minute. Would you guys watch it? Yeah? Yeah? Okay. All right, I'll try. I will pause. Yes, Jamie, I'm sorry. -100. So it was something like, we have positive and negatives. So 11 and 59, that is, what is that? 60, 70. And then we have negative. What is this, Andrew?
What?
Okay, 0, we carry 1, 7, 1, like that. So it's positive 70 minus 170, so it's negative 100. Okay, now let's go to the last slide. We are going to finish it, don't worry. And so what we're going to do now is I'm giving you the sequence. You have to come up with your own formula using sigma. It's very simple, guys. So the first one, of course. What is the first lower limit that you would use?
I equals 3.
I
Equals 3.
3. Why?
Yeah, because it has next one in the 3.
But that's actually what we're doing to every term.
Oh.
So it will be, what will be the first? 1. What will be the last? 7. There we go. And this will just be 5. Okay, could we do it in another way? Yes, of course. We could also say something like, I could start at 0 and I could even call it k and call it 0. And then instead of to get that 1 cubed, I would do something like k plus 1, right? Like a 0 plus 1, and then cube it. But then if I start at 0, what should my upper limit be? Not 7, 6. Okay? Now let's look at B. What do they all have? And I'm going to like erase this for a little bit. Lower. What do all these terms have in common?
Multiples of 3.
Yes, we're going to be using that. And also, what about the numerator?
1.
They're all ones. So let's start with that. And then Carl will give me an idea on multiples of 3. What is the multiple of 3? The whole fraction or just the denominator? Just the denominator. Very good. So we're going to cube that, right? So if we were to start, let's say, and I'm going to use n this time. Let's say I use 1. How could I get a 1 if I'm going to cube it? Well, it would just be the same, right? N to the third. So the first term will be like 1 over 1 cubed, which is 1 over 1. No, I feel like I'm doing this wrong. Wait, it's the other way. My bad.
Oh, it's to the nth power, right?
So you say multiples of 3. I should have done this. 3 to a power. There we go. There we go. However, if I put a 1 here, what am I going to get? No. I'm going to get this. 1/3. But I don't need 1/3. I need 1 over 1. So what do I need to
So
do
1 over
to that
9?
exponent?
Would be, I mean, 1 over 9 n? Would it be that?
Minus. So that way, when we start at 1, it will be 1 minus 1, which is 1 over 3 to the 0, which is 1 over 1. Would it work with the next one? Yes. 1 over 3, 2 minus 1, so that is 1 over 3 squared. Like that. And that's how we get that 1. Hey, wait. No. This is, I'm sorry.
1.
I just want to go to 1.
3 to the power 1.
This is going to be like 3 to the 1.
It's
Right?
already 51.
Oh, well, too bad. And then, so we get that, and then just for the last thing, what is our upper limit? Is it n? Or is it n minus?
N minus.
No, it's
Okay.
And actually, let me fix this, because if I use n here, I cannot use it down here. My bad. So this is n, let's make this a k, and we'll make this k equals 1. Okay, the bottom ones are exactly the same, which is square 1, and the other one we will write, it's a power of 2. Okay, so tap your things. I'll just write them here quickly in case you want to copy them.
My copy, I decide my sources. What?